I hope to speak for at least 20 minutes, maybe 5 minutes more. My name is there, my Twitter ID is there, my portal, which is work in progress, is there. So what I really want to talk about is how the NSSO data, the way it gives out the unit data, the raw data, whatever you want to call it, how it is structured, and what elements of it you need to understand so that you can convert that into a format which you can work with. Right? I wouldn't go much into the kind of analytical work we do or the kind of visualization work we do. I'll show you some examples of the visualizations we do, but really not analysis. So just to get it clear. Roughly the structure of the presentation. Okay? I begin with the pre-history. I don't want you to read the whole thing. Actually, I want to read the whole thing. I don't want to read it out myself. The reason I give these dates or give the text is, also I move a lot, I hope it's not a problem. The reason I give the text is to tell you that the NSSO, which comes to be part of the Central Statistical Organization, which was finally established in 1951, it has a very interesting and very intertwined history with the development of governance in colonial India. So it emerges as a colonial instrument of understanding the subjects, understanding the territory, and understanding how to govern these subjects, which is eventually even carried away by the post-independence, post-colonial government of India. That apart, I go through some glossaries. Some of these are specific to the software you use to extract or to convert NSSO data, which is data. You can also use R. We are also using R in some cases, but in this case I'm just speaking about data. So you have the round, okay? So NSSO, sorry, even louder. I cannot shout anymore. Yeah, mic would be nice. Yeah, no, yeah, okay. Okay, so the begin with the idea of round, right? So when you say that I want NSSO data, you go to CSO or to NSSO, to mostly is the Minister of Statistics and procurement. You have to mention the round name, the schedule name. So the round is, NSSO usually carries out rounds of surveys every year. And the round number is the number of rounds they are doing that year. So they do not mention it by year, but they mention it by the number of rounds. That's the first thing you want to know. Second is the schedule. So each year they undertake surveys on different subjects. And each subject is called a schedule. So see for 66th round, which was in 2009-10, there were 3 schedules. One was a consumer expenditure schedule. I'll get back to the main subjects for the schedules that NSSO has. And then there are other schedules. So there was an employment and unemployment schedule. There was nothing else in 2009-10. There are thick rounds and thin rounds. So they have this 5-year cycle of doing same schedules at a larger scale. For example, consumption expenditure, employment and unemployment. There would be a big survey on that every 5 years. This is called continual surveys or thick rounds. And in between the 5 years, they would still be collecting information on, say, consumer expenditure or employment or unemployment as well as other things. They're called thin rounds because they're less representative. They're thin in terms of data density they have, the number of samples they have. State region is again a very important concept if you're talking about sample data. As you understand, it's a national sample survey organization, it's not complete enumeration like census India data. So of course, when you're doing sampling, there is at least one minimum level beyond which the sample is not representative enough. If you do not understand what I'm saying, please ask me questions right now. I will do that talk. So, for example, the state region, which means a cluster of districts. So it's a region within the state. It's In a geographic size, it's less than the state, but more than the districts. That is the level, which is the least level for NSSO data to be representative of that area. For example, if you're interested in finding district level aggregates of certain variables from NSSO data, that is not possible. So that is one of the usual problems a lot of us face when we are going to NSSO and hoping to get data about districts. It doesn't really work. There are some statistical ways to do it. You take census data and you do, okay, I should not be getting into that. So there's one way of creating estimates or creating kind of weights based upon census data to have estimates from NSSO data about the district level. But it's still very muddy. It's not something very easy to do or very recommended for anyways. Fixed width files, anybody? Sorry.
So how are the districts clustered? Is it any more of a homogeneous thing or just random 3 districts are clustered?
It's usually collected districts. So it's a region, it's a geographically, there's some logic. I should say that there is a very strong logic to it regarding the economic basis of all the 3 districts or something. But at least they're adjacent districts. They're not from 3 corners of the state. Fixed width file is a particular type of data files where the width of every row is fixed. So that's why it's called a fixed width file. We'll come back to this. The do file, the .dta file, and the .smco file, right? Yeah. These are different kinds of data files. The do file is a set of data commands. DTA file is the native tabular file format, tabular data format for data. SMC is the log file. So whatever you're doing using the surface data, SMC is the file that you use to log all your commands and all your operations and the kind of messages or alerts that say is going on. I get into the schedules. Okay, so there are some schedules that NSSO undertakes during fake rounds or fake surveys. The main ones, as you can see, is contribution deployment, data investment, and what's up from manufacturing enterprises. So these are the surveys they usually undertake in the 5-year cycle. So every 5 years and every alternative 5 years, they would do a very good survey on these 4 issues. And they would keep collecting data at least about the first 3 or the first 2, the consumer expenditure and employment or employment, in between as well. But they're not as I say, the sample size is not as big as the concrete surveys, quintillion surveys. And then there are the thin rounds, and these are very interesting. So education falls in here. So maybe some of you are interested in education, participation and expenditure. So I'm very interested in the second one, particular Islam and household, morbidity, healthcare, survey of farmers and then lifestyle. These are usually the surveys. These are like lesser topics, but they do not deal with as much rigor in a way as the top ones. But they still have a very dependable, very exciting time series data on these topics as well. If you're particularly interested in certain kind of variables, you can always ask me where that would fit.
Did they change these? Are new topics added on to the thin rounds, or has it been this way?
No, they do add new ones. For example, I mentioned the manufacturing enterprises, both organized and unorganized. In 2005, 6 or 6, 7, I think they did one informal sector. So they did a redefinition of what is unorganized, what is informal, and the details of NDME, TNE, OME, and things like that. We will not get into that right now. But they do undertake new topics, but it's not very common. It's not what they would do in every year.
Thin rounds are taken every year? Thin rounds?
No, not necessarily. They are also repeated, but usually the repetition is at least 5-year frequency, or sometimes more.
So thin rounds?
Yeah, I'm talking about the thin rounds. So they're also repeated. So you get a time series, but it's not as regular as the thick round.
Like in two thin rounds, there can be 1 thin round or 2 thin rounds, maybe 4.
That's true, yeah. No, you mean each year or frequency of a particular topic?
Each year.
So each year maybe there would be 1 thick round and maybe 3 thin rounds.
Thick round is every 5 years.
Yeah, so sorry, I'm mistaken. Yeah?
Can you repeat the question? You can't hear what they're asking.
Okay, so he asked whether each year.
Sorry, the question is, do we have thin rounds every year? Thin rounds are there every 5 years. Now, do we have thin rounds every year, or depends?
Yeah, it repeats. You mean whether? Okay, sorry. Say, for example, participation expenditures in education. In the decade between 2000 and 2010, there have been only one survey on participation and expenditure in education, which is 2005. The last one, if I remember correctly, was 97. So that is roughly the frequency of repeating the thin rounds. Did I answer you well? No. Okay, thanks. I come directly to the organization of data. I'll show you some examples later on. I'm just reading through stuff right now. First, you have the fixed width file. What is important to note here is the coding is binary. For example, if there are yes, no answers in the questionnaire, yes would be say 01, no would be 02. So it's a series of numbers. There is no qualitative information present directly in the raw data file. Okay? So there are codes for qualitative answers, and you have to check it with codes later on. I'll talk about how exactly you do it. Then, of course, the data file comes with a set of supporting files. The first thing you want to look at is the schedule file. It gives the questionnaire for that schedule, that survey. So that's a questionnaire that NSSO people who went out to the field and spoke to people. That's the question they carried. Those are the questions they asked. And that's, of course, the first thing you want to look at. So that gives you the kind of variables there is in that data set. So the second file is the layout file. The layout file tells you about how that questionnaire has been mapped into the raw data file. For example, if you want to find information about a certain question given by a certain person in the raw data set, you need a file, which is the layout file, which tells you that which question, the answer of which question can be found where in the data set. It will get easier when I give you the example. Okay? The readme file gives you all kinds of codes, state codes and other codes. Because we need so all those are coded. So it doesn't say that Uttar Pradesh, that this observation is from Uttar Pradesh, it will say it's from 04. So you don't need those codes as well. The third part, and this is another layer of complexity you understand when you go on, is the level issue. So see, we have a questionnaire which is say 3 pages long. Okay. Now you remember I mentioned that the data file that we use, NSSO uses, is a fixed width file. So for example, so say in each row there is only space to fit the answer of 10 questions. Rather, sorry. So fill the answers from questions from one page. Okay? So if a person is giving out a 3-page answer, rather question set of 3 pages and answer to that, then you need 3 rows for answers from the same person. Is that clear? No. Please say no. Okay. It's not clear. Okay, so again, so say the questionnaire has 30 questions. In the data file, there is space for only answers of 10 questions in each row. So coding each answer questionnaire into the data file requires 3 rows. Yeah. Now all the 3 rows are from the same informant, from the same person who gave the answers. So you need a way to understand that these 3 rows are coming from the same person. Yeah? So that is what the levels do. Levels tell that, so levels, I go to the example is easier. So levels, what they do is that so the first row becomes the first level row for that person. Second row is level 02 for that person. Third row is level 03 for that person. It's easier when I show you. So say this is how, okay, I just want to briefly show you something else. So this is how NSSO data looks. It's very important to see this and not be afraid of this. And feel comfortable in looking at this over and over again. So this is how it looks. To come back to my point, so it's a random simulation of how the NSSO looks. Okay, that's the raw data that you get. What it means is what the layout file does is it tells you that column 1 to 2 gives the serial number of the person. Column 3 to 4 gives that, and columns 5 to 6 gives the other thing, right? So it basically tells you this. Column 1 that's the service.
Okay. Sorry to interrupt again, but it's a pretty low-level format. And I've looked at several binary formats. I can see it's fairly low-level, but seems pretty well-defined. So hasn't somebody already written a parser that just parses this and gives you a structured table? Right. Okay.
Exactly, so that's the process is about. It's parsing and...
But has somebody written an open source, something like that?
Yeah, you can use R and do it. Yeah.
No, but there's nothing ready-made because this is well structured, right? So it should be easy to generalize.
Yeah, let me add to some complexity and then it's not easy to generalize again. Okay. But I still understand that, so that's what we're doing. So we actually use 3 kind of methods to work with it. One is data, which we started using because of, again, so I come from an economics background. So it's the first software that comes to our minds, for the lack of imagination, I'm sure. Then we also use R, and then we also use Python to reorganize, parse the data, and get it into other forms. But as you see, the generality is the crucial part. I'll get to that right now. So as you see, the first row is person serial number. This third, fourth gives the age of the person. Fifth is the educational status, right? So I'm still talking about the fact that each row has a different personal serial number, right? So that means each row is for a different person, which makes things a lot easier if you're beginning to understand it. Then you have the schedule file, of course. The schedule file gives you the question. The layout file gives you which columns, and the data file has the codes for that question, and the data file has the data, right? So when the answer is in terms of numerics, it's rather easy. The number itself is the data. When the answer is not in terms of numerics, when it's qualitative data, then the qualitative data has been coded in a certain way. Maybe for some of you it's rather easy, but just going through it, I'm very sure. Now, what happens with raw data with labels, okay? Same thing, there's a layout, there's a schedule. But the thing is that for, in the example, both the rows, both the first and second rows, refer to the same person, 5 minutes. Okay. That's like 30 minutes or 25 minutes. That leaves time for discussion.
5-7 minutes including question.
Oh, sheesh, okay. What's the time? It began at 3:57. It's 20 minutes. Yeah? 2:55. Okay. So the third and fourth column gives you the level code. So for the person serial number 1, 2, the first is 01, the second is 02, as I was talking about. But then what happens is, the first row, the 1, 2 refers to the age of person. In the second row, 1, 2 refers to the education qualification. So the columns are not static. Columns are moving all the time. There's another level of complexity which I haven't brought here, which is that column width could be different. For example, say this one is not age, but say this one is number of days you work in a month, right? So it's a 3, yeah, in a year. Yeah, sorry, in a year. So it's a 3-digit column. So there would be for different rows, the column width is different and the column heading is different. And that is what makes usually parsing very difficult. I mean, whatever you do, even if you're using something like Python, you still have to manually code each time you're extracting a data set.
The specification isn't codified already.
It's not. I'll show you how it's given.
But it is documented, right?
It is documented, yeah. I mean, otherwise, how would I? Yeah.
Yeah,
So this is the form.
You first parse this and then you parse that.
That's true, but then this is the latest one, 66, right? If you go back to say like 56, like 10 months back, this thing is in PDF, which is a scanned PDF. So yeah, we tried all that and it didn't really work out. And at the end of the day, it's easier to just write it down. Okay. Okay, I'll be quick. I'll just show the kind of coding we use. This is also coding tree. So this is data code. You cannot see from there, right? Yeah, it's better code. Anyhow. So this is again. What is this? Okay, this is some other stuff. I'm sure. So it's not what I want to show. Yeah, so this is what I want to show. So you see the infix command, that's the command you use to specify what column is doing what. Then you take it for each row, then you give a if condition that if only variable code is this, take this column, otherwise the column headers become different. So that's one thing. There's not much to show here. I just want to show you. So this is how it looks again. This is after doing the entire conversion. I don't want to show that. So taking from that, what we usually do, we use R and we do Google-based library from R to do this kind of visualization, to do this NSSO. It's quite exciting, I think. So it's 1951 to 2004. You understand the side of income? 2 minutes more? Yeah, super. So, you decide on income. For example, if you order the entire population in terms of income, and you have the bottom 10%, the next 10%, the next 10%, the next 10% up to the final 10%. Then, for 1951, this is the average income of the bottom 10%, and so on. This is the average income of the top 10%. Okay. So we plotted that from 1951 to 2004 to see what kind of movement is happening throughout the years, okay, for different income classes. And it's quite exciting. Of course, we are quite, touched by Hans Roslin's methods and the wonderful possibilities of Google chart libraries, as you can. Yeah, so you clearly see the income discrepancy that people talk about. Okay.
Are you building the technical thing? The question is technical.
Yeah, sure.
Where are the dates?
Right. So there's a column. Just for the recording.
Yeah, the question is about the weight. Every sample person will have a sampling weight. So where is it stored in the data? And number two, linked to that is where is the primary sampling unit number and all those things. They are associated with every household data.
So the weights are given for each row. So there is one column which gives the weights at the end here. So that's standardized. C is the metadata about the sampling related metadata. So for each row, say a row, if a row is 150 digits long, then the first 30 would be about the sampling metadata. 31 is usually 35, 36 or 34, 35 is the level code. And the rest is the questionnaire. So that's roughly it. Usually 140, 141 or 142, 43 would be the weights. There's some blank space as well. So that's roughly how it's organized. This is another interesting, this is from DICE data, which is District Information System for Education. This is one thing we are doing at great length in the university because the university is so much interested in education. So we are looking at, so we have only data for 2005-2009 for DICE, but we're looking at all the states in India, and that's quite an exciting thing. So if you look at the number of teachers and percentage of regular teachers, what is funny is there are, Sorry, I didn't want to do that. What is funny is some states like this Jharkhand, where there is a very fast decline in percentage of regular teacher. At the same time, it's not that. So there is one argument in education, world about percentage of regular teacher fall, but the number of total teachers is increasing, so it's an increase in employment, right? So that kind of argument. That is not working either. It's roughly the same, right? So what I wanted to say is visualization. So my talk is really not about visualization, but I still want to say that it's amazing to understand the fact peculiarities of the data. So if you want to take a look and see where there might be some possible research areas, you go to Jharkhand and see what's happening in education area. Okay, it's quite amazing to do that. Thank you very much.
The green circle which went all the way to the right and then they went down.
Okay, Mizoram. So yeah, it's difficult, no? Okay, so I just want to do this one?
It's like ping pong. What is
this one? Someone question. This one?
Yes, we'll take
This one? What is such a physical? So it's also it's a good way to understand the data discrepancy, right? Clearly there is problem with data, right? So that has been our major research finding from using RISE data for 4 years and cleaning it up and spending endless hours, and all we find is that it's impossible to make any sense of RISE data because it's completely, I'm sure some of the states are cooking up RISE data, which is supposed to be the best education data set in the country for its computer innovation. So yeah, so there are those days as well. It's still enriching in some ways, I'm sure.
So what is the assessment of NSSO data?
NSSO data is amazing.
How internally consistent is the NSSO?
In our finding, it's perfect. The thing is that, say, there was change variable levels from year to year. And we're talking about, say, 20 years of data, right? So we are right now what we're working on. So we have here 1951 to 2004. We're trying to do a work on change in consumption pattern from 91 to 2010, 2009 really. Okay, so it's 20 years of data and detailed consumption pattern including rice or different kind of food items and stuff like that. And it's a nightmare again because they're changing variable headers and we have to homogenize that, and they're changing states, changing districts. Okay, that completely throws you away. And kind of so they have changed it twice between these 20 years, and the new states, new districts coming up. It's exciting but it's difficult. Yeah.
Can you talk about the mechanics of obtaining the rest of the questions online?
Python.
No. Can you talk about mechanics of obtaining this data?
You write to must be, they sell it to you.
And 8,000
sometimes more. Depends on, so the different CDs cost different things also, so it's funny. Usually, yeah. So